Okay, so I'm now going to do the fifth lecture of this course, and it's about branches. So what is a Git branch? Well, you may have gotten some idea of it from the other lectures, but officially it's a pointer to a commit, a ref, a named pointer, and is defined as all points reachable in the commit graph from the named commit, from the tip of the branch. And the ref head determines what branch you are on. So if head is a symbolic ref for an existing branch, then you're on that branch. And if it's a simple ref directly if head is a simple ref directly naming a commit by its SHA-1 ID, and you have seen that several times now, you are not on any branch, you're in a detached head mode. And you got an example of that yesterday. And that happens when you check out some earlier commit to examine, for instance. So why would we use branches? Well, there are many uses for branches. You could want to develop new features, maybe without wanting to risk changing to the main code that you have now and that you know are working. Or you want to maybe go in a different direction for a project, see how that will work. Or maybe each of the project members would like to work on their own copy of the code without messing with each other's code. And you could also have bug fixes that are not yet tested. And those you will then maybe merge into the main version. And that also goes, of course, to the new features and the other ones. So in the exercises we have had to now, we have mostly worked on one branch, and the commits are done one at a time. And here in this picture, you can see the master branch points to a commit, and the position is head. So let's look at some basic concepts of this. You have a repository which has several branches here. It has the branch's new feature and the cool feature aside from the master, or main, as you found that it's called some places, but it doesn't matter if it's called master or main. It depends on the version of Git, and I think also the operating system. So the branch is the commit and also all the parent commits. It's not just the one we are pointing at, and that's important to remember. And the main line of development is usually called the master branch or the main branch. And these different branches within a repository, you can have completely different files and folders in it, or maybe it's almost the same except for a few lines of code in one of the files where you want to test something. I mean, branches can be very different or they can be very similar. So let's assume that here we are working on a new feature, the cool feature or the new feature. And as soon as it is completed, we merge it back with the main master branch, as you can see here. So there are some commits here, and then we merge it back. And here we also, here the branches split. We do some new ones, and then we merge it back. So that is a very common way of doing different branches. Of course, it may be that you have a branch where you test out something and you find that this is not a good idea, and then of course you are not merging it into the main branch. So how do we create a branch? Remember that when you create a new branch, it doesn't change the repository. It just points out the commit. And the branch is created from the current head. So if you want to create a new branch, which I will call cool feature in the following, you use the command Git Branch cool feature. And if you want to move to another branch or switch to it that already exists, it's git checkout the name of the branch here, cool feature. If you want to switch to a new branch that is not yet created, you can do that as well. And then you add the flag -b to the git checkout. And if you want to see which branch you are on, then you just do git branch. So when you have decided that you're happy with those changes you have, then you can merge it back to the master branch or to another branch, or of course create more branches. And remember again, the branch is always merged to the current head. So you first switch to the branch you are merging it to, and you do that. If you're, for instance, merging to the master branch, you say git checkout master first. And then you merge them with git merge and the name of the branch that you want to merge into the master branch. And since we have now merged them, there's no reason to keep the extra branch unless you want to use it further for testing. So just delete it with git branch -d and the name of the branch that you are deleting. So let's look at an example. Let's first create a directory and initialize a repository. Then we create a file, we stage it, and we commit it. So in this example here, I will create a directory. I call it my project. I change to it, and then I initialize it. And then Git, as we have seen before, tells us that it initializes an empty Git repository with this name. Then I'm going to create a file that I do with the touch file. And then I'm adding this file into the repository. And I'm committing it. And I'm remembering to make a comment. And in this case, I'm using the option where I add the commit directly when I'm doing it here. I could also just say git commit, and then it would open the editor and I could write into it, and then I will save and exit the editor, and it will then do the commit. But it's also possible to just give the message on the line when you're doing the commit. And that is often the easiest way if it's not a very long message you're using. So then Git will give you some, say something here. It says that it is committing the first file, and it tells you that it changed one file and that it creates this in the repository. So all is well. So then let's try and create a new branch and switch to the branch. And let's then do some changes, like we're adding some files and text to the new branch. And then we stage the file and commit it. So I create the branch here. I check it out. So I switch to it. And Git tells me this, that I have switched to this branch. And then I will put some stuff into this file that's called file.txt. And I'm doing that directly on the command line with the echo. This is a text, then throwing it to file.txt. And after having put this information into the file, I will add the file, which I now made changes to, and then I commit it and saying I added text to it. So now we have some text in this file on our new branch. Then I will try and switch back to the master branch and then do some changes there. So I switch to the master branch. And then I put stuff into yet another file and add it and commit it. Now we have a file that is different on the master branch and a file that is different on the new branch. So let's again use the git log command to see what the effect was of these changes. So on the master branch, it looks like this. So you can see you added text to the first file, you added a second file, and then you committed the first file. So let's try merge in the branches and see again what happens. I'm trying to do a merge of my new branch into the master branch. And that actually goes well. It does a merge by the recursive strategy. And since now we have merged the branches, we can delete the new branch we created. And I do that with Git Branch -d, the name of my newly created branch. And it then tells you that it deletes it. Oops, sorry, yes. So as you can see here, I have tried drawing with it here. So you can see this is a master branch with some commits, and the new branch with some commits, and they both came from the original. So now it's split. And this is how it would look when you merge the branch to the master. And then afterwards you delete it. So you can see now we only have the master branch, which points to the newest commit, which is the one after we merged into it here. So what happens if you are switching when you have uncommitted changes, because that sometimes happens. If you have been working on your cool feature or something, or on your bug fix, and then you decide to switch back to another branch, or maybe the master branch, to do something there before you commit the changes that you have on the new branch. So you switch, and now you have the uncommitted changes. What happens then? Then the uncommitted changes will be carried to the new branch that you switch to, which may or may not be what you want. And those changes that you now commit, they will be committed to the newly switched branch. But there could be a conflict. What happens then? Then it will not allow you to switch to the other branch, and tell you that you must first either commit your conflicting changes, or you must stash them, which we also talked about yesterday, stashing. So here we have an example. We create a new branch, we switch to it, and then we add a new file. And then we will afterwards switch back to the master branch without committing the changes and see what happens. So we create and switch to a new branch that I call cool feature. Then I create a new file on it. I add this file, and then I try to switch back to the master branch. And when I do that, I am told that there is this file here, Git complaints, but it's not a problem because there is no conflict. So it switches to the master branch. And what then if we make some changes to the file in one of the branches, but not on the other, and we do not commit it? We do that here. Again, Git tells you this file is modified, but it allows the switch, even though there is a change in one branch but not the other, because there are no conflicting changes. What then if the changes were actually conflicting? So assume you have two branches. You have the cool feature, and then you have one other one, which you call more features, maybe. So you switch to the branch cool feature. You made some changes to a file, stage the file, and commit it. So we do that here. We add text, and then you add that, commit it. Okay. But then we switch to the branch more features. We modify the same file, and then stage the file and commit it. And after we have done that, we try and switch back to our other branch, the cool features branch. And when we do that, Git is not happy. You can see here, your local changes to the following files would be overwritten by checkout. And then it tells you to please commit your changes or stash them before you switch branches. And it's not allowing it. So what can we do now when we have a conflict? Well, you could commit the changes before you switch the branch, or you could stash the uncommitted changes. And you could, of course, also simply discard the uncommitted changes. Or you could do a checkout with merge, which may or may not be dangerous. So let's try and see. We do a git status on the branch where you have some uncommitted changes. And it tells you, as you know, there are these files here. And you can see there's a dirty status of this. So we can fix it. We try fix it with git stash. And then it tells you that it saves the working directory and index state on more features. And then it will allow you to check out. You can see here, if you do a git status to see what it says your working tree is clean and you have nothing to commit. So fine, you can switch and work on something else. Let's assume you don't want to stash your changes, or you just want to get rid of them. You can do that with git clean. But remember, it removes all non-tracked files in the current directory. So just be aware of that before you do this. And you can also safely test which ones will be removed if you run git clean and then add the flag -- dry run. So we had another option, which was that we could do a merge. And you can do that if you simply add the flag -- merge or -m when you do the switch to the other branch. So you do git checkout -- merge and then the branch. And in this case, it will perform what is called a three-way merge between our working tree and the new branch with the current branch as the base. And that can go well or it can go badly, but it depends. And you should know, I mean, if you have some conflicts that you know will be harmless, then you can just go ahead and do it. But so after the merge, you will now be on the new branch and the merged result will be in your working tree. And again, remember, there could be conflicts that you will then have to resolve. So merge conflicts. They will inevitably happen now and then when you are working with more than one branch and you try to merge them. And in many cases, Git can fix this for you without any problems. But sometimes there will be a merge conflict that Git cannot automatically fix. And it will give you a message then, something like this. So you see, it will say error. For instance, there is something in this file. It would be overwritten by the merge. It cannot merge, and there's changes in the staging area. Then you have to do something yourself. One thing to remember, yes, always check you are on the right branch before merging. Remember, you can check it with Git Branch. And you can try to say git merge and the branch you want to merge to when you are standing on the branch you want to merge to. So there are different merge strategies. The most commonly used ones are the fast forward merge. And in this case, the commit history is one straight line. You create a branch, make changes there, but you make no changes to the master. You then just merge it back onto the master. This just moves the pointer for the master branch forward in a straight line. This is harmless. You can do a recursive merge. You make a branch, you make some commits there, and you also make commits on the master branch. Then when you want to do the merge, Git will recurse over the branch and create a new merge commit. The merge commit will continue to have two parents. So let's look at an example of a merge conflict. So I will try to create a merge conflict. So I create a directory to do my stuff in and switch to it and initialize it. So I have now my new repository. I will create a file with some text to play with, and I put it into the file myfile.txt, add it, and then commit it. And then I am now going to create and switch to a new branch that I call merge branch here. And then I put more stuff into this file that I just created. Then I add it again and I commit it. I switch now back to master and I put more stuff into the same file and add and commit it. And then I try to merge them. So I say that and I now want to merge the merge branch to the master file. And it's trying to do an auto merge of the file that we now made changes to on both the branches. And Git tells you there is a conflict, and also that the automatic merge failed, and that you will have to fix the conflict and then afterwards commit the result. And you can use Git status again to see what is going on here and what is the problems. And it tells you that you are on branch master and that you have some unmerged paths. Here. The myfile.txt is modified on both branches. So let's look inside this file, myfile.txt. And as you can see here, Git has put some conflict dividers into it to tell you what the issue is. And what is the easiest way to fix the merge conflicts? Well, you can edit the file yourself, and that is a very direct way to fix it. And then when you have done this, you can repeat the merge with git merge -- continue, and then the branch you were merging to. So you just continue. And the commands to help with this is you identify the conflicting files. You use git status for this. And you can use git log -- merge to get a list of commits that conflict between those branches that you're trying to merge. And remember, you have the command git diff as well, where you can find differences between the states of a repository or the files. So you could, if you want to simply reset the conflicting files to a good state, you can do a git reset. And let's say you made a mistake when you resolved the conflict and you have also completed the merge before you realized there was this error, but now you see there's problems. You can simply roll back to the commit before the merge was done with git reset -- hard. So let's look at the workflow where the merge goes well. So you do some work on some files, you stage the files, you commit the files, and then you do git merge to this other branch, and it all goes well. And what when it goes badly? You work the files, you stage the files, you commit the files, then you try again to do the merge, and there's a conflict. So these are, and then of course you fix the problems, and you stage it, you commit them, and then do the merge. So the merge continue, and then you have success. So these are two typical workflows. So what is rebasing? It is a process of moving or combining a sequence of commits to a new base commit. It will solve the same problem as a git merge. And the commands are both used to integrate changes from one branch into another branch. But the way they do it is very different. When you do a rebase, all the changes will be compressed together into a single patch, which is applied. Rebasing creates new commits on the other branch for each commit in the original branch. So let's make an illustration of this. So the branch bug fix was branched from master here, as you can see. Branches out here. And if you're rebasing bug fix to the master branch, you will then have like this. So these are where the patches are applied to it. So let's assume a master branch, and we also have the branch cool feature. And let's assume that you want to rebase the branch cool feature to the master branch. So you go here and switch to your cool features branch, and you do a Git Rebase Master. So you can see in this case, you actually stand on the branch where you rebase it, that you will rebase to the master branch. So, well, how does this work? It will go to the common ancestor of the two branches, so where they split. And it will then make a diff for each of the commits on the branch you're on. It will save the diffs to a temporary file. And then it will reset the current branch to the same commit as the branch you are rebasing onto. And then it will apply each of these changes you did in turn. So it's a clearly different way of doing this than to do a merge. So you could think that rebasing and fast forward merge was the same, but it's not. A rebase moves a branch from one base to another, whereas a fast forward merge moves a branch head from the current commit to a commit for a descendant. So here is an example where you can see you have here a commit, then you split it to the branches here. And you have now at the start here, it looks like this. Then we would like to rebase the B branch onto the C one. And you do that here. It looks like this. So C is still here and B is here. And what then if you did a fast forward merge to A? Well, for a while it looks the same, but then it doesn't look the same at all, as you can see. And C and A, they both now point to this commit here. So what is cherry picking? Well, basically, if you are doing what is called cherry picking in Git, that means that you will choose one of the commits from one branch that you will apply to another. So it's a specific commit you are picking from one branch and applying it to the other branch. So you will use git log to find the hash for the commit that you want to apply. And then when you have done that, make sure you have switched to the right branch. So do git checkout to the branch. And then you will execute the cherry picking. So you say git cherry pick hash, the hash you got from the git log. So I think that this is now the time where we are going on to the exercises. And there will be 5 exercises for this section. And in each of the exercises, there's a readme.md file which has explanations and descriptions of what to do. They will all be in the subdirectory 5.branches. And you should do them in the below order. So there's first one that's called fast forward merge, where it will go okay. And this is an exercise that shows an example where Git can do a fast forward merge. It is in the subdirectory 1.merge okay. Then we have one where you do a recursive merge. And in this example, Git is able to do automatically merge between 2 branches. And you can find this exercise in the 2.merge -OK -recursive. Then let's look at an example where merge goes badly. And this is an exercise where Git cannot do the automatic merge. And it will be in the subdirectory 3.merge bad. Then we have an example of rebasing that goes well in the subdirectory 4.rebase -OK. And then finally a rebase that goes badly. And this exercise again gives an example of rebasing, but now the rebasing fails. It can be found in the subdirectory 5.rebasebad. So this is my directory. I'll move it slightly so I'm sure it can be seen. You can see here are the different directories, and it should be under course intro Git materials, and then you go into 5 branches, and then you find these 5 directories. So we could try go into the first one. Let's move this. Okay, so I have this one.merge.ok. So look what's in it. And you can see here is the README file that tells you what to do. And then there is a repository called recipes. And you will be doing these examples in this repository. So you would change to it like this. And then you would be able to do some various work on this one here. But let's see what it says in the README file. So the example here says merging 2 local branches, and then you have a description of the exercise. And first, I just want you to do a git status and look at the status. And then you try to do a merge. And there is some information here about what you should do. I think the exercises should not be that hard. So I think you should be able to do them in maybe 15 minutes. Let's see what's due.